Now this illustration deals with performing the actual calculation, which two calculations have to be performed, and you select the calculation that will provide the largest conductor. Now, to the left of the illustration here, we pick up sizing the conductors based upon the 1/3 rule. So again, the 50 horsepower motor has a full load current rating of 143 amps, and naturally we could obtain that value from table 430.250. In some cases, maybe the nameplate, depending on if they're equal or greater, or however that full load current rating would be selected. Now notice in step 2, 430.22, and remember, we could look at sizing conductors and capacitors by referring to Article 430 and obtaining the part that deals with sizing conductors from Article 430 in the table of contents around page 4 or 5 in the front of your code book. And notice we would pick up when we go to Article 430, Part 2, and scroll down, 430.22, we take 125% of the 143 amps from step 1, and we come up with 178.8. Step 3 will select the conductors, and always the golden rule we would apply, 310.14A3, informational note 2, which states calculate the load. So table 310.16, from calculating the load in step 2, the 178.8 would require a 3/0 conductor, THWN, which that's the insulation on the conductor that we're using, copper, would be 3/0. Step 4 now, the 3/0 is equal to 200 amps. That's the ampacity in the 75-degree column, because 110.14C1 A and B, or I think it's A1, little a, and then little b, we would pick up 1/3 of the overcurrent device because we're over 100 amp. So we'd pick up 1/3 of that, and it'd be 66.7. So that's why we use the 75-degree column, because the ampacity is over 100 amp. Again, look at table 110.14 C1 A and C1 B, I believe it is. Now, when we do the math in step 4, we come up with 66.7 amp. 66.7 amp requires a number 4. So in the solution, based upon the 1/3 rule now, we would pick up a number 4 THWN copper conductor. Now let's apply the second calculation, sizing the conductors based upon the 135% rule, which is to the right of the illustration. So we would look at the full load amps that we would have to find of the capacitor. It's a 25 kVA capacitor times 1,000 divided by the square root of 3, because it's 3-phase. So when we take the square root of 3, then we would have 25 times 1,000 divided by 208 volt times the square root of 3, 1.732, 69.4 amp. 460.8A requires the 135% rule to be applied, so 135% of 69, 93.7. Again, we're applying the golden rule, 310.14A3, and we're looking at that informational note 2 again. We calculated the load as required in step 2. So the 93.7 amps requires a number 3. So based upon the 135% rule in the solution, we would need a number 3. So which is the largest? The solution of the 1/3 rule or the solution of the 135% rule? Where the 135% rule produces the largest conductor. So, as the note points out, 460.8A requires the largest conductors calculated. So that would be at number 3, THW and copper conductor. So we would use those size conductors from the controller to the capacitor. And we have completed the two-step calculation procedure. And we find number 3 is the largest conductor. So that's what this illustration 18-56 is pointing out.